All right, today we're looking at circles. This is the first day of circles. So you should have in your notes from class these things that I have below. If you weren't in class, then you're probably going to want to pause and write this stuff down to start off your circle notes. But just as a general overview, your standard form of a circle is x minus h squared plus y minus k squared equals r squared, where your center is at hk and your radius is r. First example, if I give you the equation x minus 2 squared plus y minus 3 squared equals 9, your center is at 2, 3. Again, we're going to change the signs because we have that minus in our equation. And my radius would be 3. R squared is equal to 9, so if we take the square root of that, my radius is 3. If you plot your center at 2, 3, you count up 3 units, down 3 units, right 3 units, left 3 units, then that'll give you the general shape of your circle. On example 2, it gave us the center of 0, 3 and a radius of 2, so we went ahead and plotted that. Plot the center at 0, 3, up 2, down 2, left 2, right 2. Then when we go to write our equation, because my x term would be x minus 0, which is just x, we're going to write that as x squared. And then we have y minus 3, again changing your sign, squared equals 4 because we need to square our radius. So the other thing we want to look at when we look at circles is their lines of symmetry. So if you think about a circle, I'm going to switch to here. When you think about a circle, wherever it's located, it's going to have a ton of different lines of symmetry. Here's my circle. I can draw a line of symmetry right here. Oops, assuming that went through my center. We'll draw my center a little bigger so it looks like it does. We could have a line of symmetry that comes this way. We could have one that goes this way. Anywhere we draw a line, so long as it goes through the center of my circle, it would be a line of symmetry. It's going to cut that circle in half. So we know that all lines of symmetry go through the center of the circle. Okay, so if you have a circle that has a center, we'll go back to our one at 2, 3, and had a radius of 3. If you think about the equation y equals, let's see, 1/2 x plus 2. When you graph that line, you'd start at your y-axis on y value of 2. Then we'd go up 1 over 2 units, up 1 over 2 units. If you look at that line passes through the center, so it is a line of symmetry. So you can make up different equations that'll go through the center based on your slope and your y-intercept to make sure that it's going to land through the center. If you're given a bunch of equations, then you can graph them and see if they go through that center point. But the big thing to keep in mind is that in order to be a line of symmetry for a circle, it must go through the center of the circle. The next example I want to look at is one more where we write the equation and graph it, but I give you a little bit different information. So this would be your example 3 of graphing them. If I tell you that the center is at 0, 0, and it passes through, so we're going to say it passes through O-U-G-H. Let's say this one passes through the point 3, negative 6. So if we go ahead and we start graphing this, our center here is at 0, 0. It goes to the point 1, 2, 3, 1, 2, 3, 4, 5, 6. It goes to the point 3, negative 6. So we know that this line that connects these is equal to my radius. If my center is at 0, 0, we know the first part of my equation is x squared plus y squared because we'd have x minus 0 and y minus 0. That's going to be equal to my radius squared. So we need to figure out what my radius is in order to do that. So we need to know the distance of this line. You can do this one of two ways. You can use the distance formula, which I'll give to you on your formula chart, or you can use Pythagorean theorem. They both work the same way. The distance formula is just a rearranged version of the Pythagorean theorem. So if we look at this one, we look at Pythagorean theorem wise, you're going to look at your A value and your B value. So here this vertical distance is 6 units. This horizontal distance is 3 units. We want to find my diagonal, so Pythagorean theorem tells me that 6 squared plus 3 squared is equal to that diagonal, my C, but in this case it's really my radius, is equal to my radius squared. So we have A, B, and C. 6 squared is 36. 3 squared is 9 is equal to my radius squared. So my radius squared is equal to 45. Now, if we want to finish, which we need to finish graphing our circle. We want to go ahead and figure out what my radius is. So my radius is equal to the square root of 45, which is about 6.7. Okay, so if we go through and we want to graph this out, 1, 2, 3, 4, 5, 6, almost 7. 1, 2, 3, 4, 5, 6, almost 7. 1, 2, 3, 4, 5, 6, almost 7. That way we can graph my circle, can finish the circle graph. Then when we go to my equation, remember my equation is always equal to my radius squared. So we're going to come back down here and we're going to go to this line that tells us what the radius squared is, which was 45. So the equation of this circle would be x squared plus y squared equals 45. This should be an integer so long as your x squared, your a value, and your b value were integers.